In this lesson, we're going to talk about how to involve integration with data tables. So instead of being given an equation or a graph, we're going to have a table of data, and we're still going to have to find the integral values. Be sure to set up your paper as Cornell Notes, and you do have the examples on a worksheet, so you can include those in your notes. Remember, when we're talking about finding integral values, we're talking about finding area under a curve. Again, the difference today is going to be in the information that's given. So here's our first example. We're going to be looking at water flowing into a tank over a 24-hour period. I don't have an equation measuring this. Instead, I have a table that's giving me the rate the water is flowing into the tank at certain hours. So T represents hours. R of T is the number of gallons per hour that are flowing into the tank. And there is one other very important piece of information that's given to you here, and that is that the tank contains 150 gallons of water when T is 0. So we start with 150 gallons of water. Okay, now the data that's in the table I've represented as a scatter plot. So if you think about it, this is our time versus our rate. Okay, so if you think about this, we're still, if we're asked to find an integral, looking for area under the curve. So if it helps, go back to the scatter plot and think about what's happening on the graph. Okay, in the first part, we're going to estimate the number of gallons of water that have flowed into the tank over the 24-hour interval using a midpoint Riemann sum. Okay, so we're going to go back to our methods of left sums, right sums, midpoints, and trapezoids. Okay, this one says to use 3 subintervals and the values from the table and show the computations that lead to your answer. Okay, so first let's break this up into our intervals. So we have the time interval from 0 to 24. So if I'm going to take that 24 hours and divide it into 3 subintervals, that means I want to split it up into 8-hour increments. So I'm going to have an increment from 0 to 8. I'm going to have one interval from 8 to 16, and one that goes from 16 to 24. Okay, so to estimate with a midpoint Riemann sum, the number of gallons of water would be the integral from 0 to 24, but again, we're estimating that integral of R of t using a midpoint sum. Okay, so midpoint means we're working with rectangles, and if I'm working with rectangles, then I need my length times my width. Okay, and the width of the interval is going to be 8 in all of these cases, because from 0 to 8 we have a difference of 8, from 8 to 16 a difference of 8, and from 16 to 24. So these are all even, but it doesn't always have to be. So in my first interval from 0 to 8, my width is 8, and my height is going to be based on the midpoint. Well, the midpoint of 0 and 8 is 4. So I'm going to use f of 4, the function value when x is 4 or t is 4, as my height. For my second interval from 8 to 16, my width is still 8, but the midpoint of 8 and 16 is 12. So I'm going to have to use f of 12 as my height. Okay, and for our last interval, 16 to 24, my width is 8, but the midpoint of 16 and 24 is 20, so I'm going to use f of 20. So to estimate my integral using this data, I'm going to plug my numbers in. So I would have 8 times 8.8, which was the f of 4. 8 times 9.2. 9.2 is your f of 12 from the table at the top. And f of 20 is 8.1. And when I multiply and add these all together, I get 208.8 gallons. So in 24 hours, there have been 208.8 gallons of water added to the tank. Okay, so if I want to know how much has flowed into the tank, okay, then that is the amount that has been added to the tank in those 24 hours. but on your paper it also says to estimate the number of gallons of water in the tank at the end of 24 hours. So if I want to know how much total water I have in the tank, then I'm going to take my 208.8, which is what has added to, plus the 150 gallons that it started with, and I would come up with a total of 358.8 gallons of water. Okay, so that was using the midpoint sum to estimate our integral, or estimate how much water has flowed into the tank. Okay, now this next time, let's estimate the number of gallons of water in the tank using a trapezoidal sum. Okay, so we still have the same data table, but this time we're going to use a trapezoidal sum. We still want 3 sub-intervals, so it's very important that you read to see how many intervals you want and what type of estimation you're going to make. Okay, and again, we want the number of gallons in the tank at the end of the 24 hours. So don't forget that the tank has 150 gallons of water when you start. But let's do our integral first. So with a trapezoidal sum, 3 subintervals, I'm still looking at the interval from 0 to 8, from 8 to 16, and from 16 to 24. And remember, the area formula for a trapezoid is 1/2 times base 1 plus base 2 times the height. And the height is going to be like the width of our interval, because the trapezoids are actually sideways. Okay, so our height is the difference in our interval. Okay, so for our first interval from 0 to 8, I'm going to have 1/2. Base 1 and base 2 are going to be the endpoints of the interval. So the endpoints are 0 and 8. I'm going to use those y values for my base 1, base 2. So 8 plus 9.3, and then times the height. Well, the height of the interval is 8, the 8 minus 0. Okay. For my second interval, my formula is 1/2. My base 1 and base 2, okay. So for base 1, I'm going to use the 8 again, which is the y value of 9.3. And then my base 2 would be the f of 16, or 8.9. And the width of the interval is, again, still 8, because from 8 to 16, I have a difference of 8. Okay. Now for the last one, 1/2. My base 1 is f of 16, or 8.9. My base 2 is the f of 24, because my interval is from 16 to 24. So f of 24 is 6.7. And then again, my width of my interval, 24 minus 16, is still 8. So that's the height of my trapezoid. Okay, and when you add and multiply all of that together, you come out with 204.4 gallons of water that have been added to the tank. Okay, so the total number of gallons would be the 204.4 plus the 150 that we started with, giving us a grand total of 354.4 gallons of water. Okay, now the next part of this problem is not using the data table. This time it says a model for the function is given. So the model of the function is the equation. So we have an equation now to work with. And we want to use the model to find the number of gallons of water in the tank at the end of 24 hours. Okay, now again, remember we started with 150 gallons of water. Okay, to that we're going to have to add how much water has been added to the tank, which would be the integral from 0 to 24, because we want in the 24-hour period, okay, of our equation 1/75 times 600 plus 20t minus t squared dt. Okay, you can integrate that by hand, and I'd like you to pause the video and do the integration, and then you can turn it back on and check in just a minute. Okay, so when we integrate, we're going to come out with 207.36. We add that to the 150, so the total amount of water in the tank is 357.36 gallons. If you did not come out with the 207.36 from your integral, then you need to put a question mark in your notes so that if you can't find your mistake, you can ask about it in class. Okay, now part D, we're still using the equation. We're not using the table. We are using the model given in part C. So we're using the equation to find the average rate of water flow. Okay, and W does represent the rate of the water flow. Now notice this does not say average rate of change. It wants the average rate. We've been given an equation for the rate. So this is the same thing as saying I want the average value of the rates. Okay, so average value formula is 1 over b minus a, the integral from a to b of water flow, which is our W of t, dt. Now, we just found that integral in the last problem, and our a and our b are going to be the 0 and 24. So I would have 1 over 24 minus 0, or 1 over 24. And then my integral value that I got from the top part, this part right here, which we found earlier, was the 207.36. So when I multiply that times 1 over 24, you're going to come out with 8.64 gallons per hour. That is the average number of gallons that were added per hour. Doesn't mean that 8.64 is in the table, but it does mean that on average 8.64 gallons were added to the tank every hour. Okay, we're going to look at one more example. This example, you'll notice, does not use even intervals in the table. So I've got an interval from 0 to 5, which is a difference of 5, from 5 to 9, which is a difference of 4. So my intervals are not evenly spaced. Okay, so that is not really going to change the way we work the problem. It's just that our W, or our width, is not the same every time. Okay, now one other thing that I want you to notice in part A is that it's asking us to explain the meaning of the integral, not just to calculate, but to explain what it means. Whenever you are asked to explain the meaning of a derivative or an integral, I want you to think of this acronym, NUT. You need to give the noun, the units of measure, and the time interval. So all three of those components need to be a part of your explanation. So let's see how this would work for the integral that we're given. Okay, so the noun refers to what we're actually finding. So if I am integrating v of t dt, when I integrate v, velocity, I get back to position. So my noun needs to be the position of the particle. So the integral from 5 to 17 of v of t dt is finding the position of the particle, or how much it's moved, it's actually the change in the position. Okay, now I need the units. The U stands for units. Okay, so if you'll notice up here in the table, my velocity is in meters per second. Okay, so my position, the change in the position of the particle in meters, okay, over, and then the T is for time, the time interval from 5 seconds to 17 seconds. Okay, so have I covered it all? Do I have the noun? Well, the noun is that I'm finding the change in the position of the particle. Okay, so that's my noun. Okay, and my unit is meters. Okay, I should actually spell that out just to be certain. Okay, in meters. And then my time interval was from 5 to 17 seconds. That is what your integral is calculating. Okay, so noun, units, time interval. Okay, so now they want us to calculate that using a left Riemann sum. Okay, and notice we only want from 5 to 17, and we want 3 subintervals indicated in the table. So if I'm starting at 5 and I'm ending at 17, they've given me some extra numbers here. So I'm just going to get rid of those two parts of the table that I don't need. Okay, so my 3 intervals, my first interval would go from 5 to 9, and then I would have the interval from 9 to 12, and then from 12 to 17. Okay, and this time I want a left Riemann sum. So a left Riemann sum is using a rectangle. Okay, so we're going to do length times width. The width of my first interval from 5 to 9 is going to be 4, because that's a change of 4. Okay, times the left endpoint. Well, my left endpoint is the 5. Okay, so I'm going to do times f of 5. Okay, on my second interval from 9 to 12, my width is going to be 3. That's the difference between 9 and 12. And then I'm going to multiply times my left endpoint, which would be f of 9. Okay, and on my last interval from 12 to 17, okay, my width is 5, and my left endpoint is the 12. Now, if I had been doing a right sum, instead of f of 5, f of 9, f of 12, I would have used f of 9, f of 12, f of 17. Okay, so read very carefully to see what kind of sum you're finding. So this first one is going to be 4 times using the numbers in the table. F of 5 is 6, f of 9 is 10, and f of 12 is 15. So when I multiply and add all those numbers together, I get 129 meters. Now they didn't tell us where the particle started, but we know it moved 129 meters in the time from 5 seconds to 17 seconds. Now, part B, read very carefully. Okay, again, it's going to ask us to explain the meaning, but let's calculate the integral first. It's asking for the integral from 12 to 17 of v prime of t dt. Well, what is the derivative of velocity? It's really acceleration. Okay, so I'm trying to find the integral of acceleration. So the integral of v prime, if you're integrating the derivative of v, you get back to velocity. So integral of acceleration is velocity. So this, in using our fundamental theorem, this would be v of 17 minus v of 12. Those are numbers that are given to you in the table, because the table gives us v of t, not v prime. So v of 17 is 21. V of 12 is 15. 21 minus 15 would give us 6, and this is, since we're talking about velocity, this is 6 meters per second. Okay, so let's state what this means. Again, remember we want noun, units, and time. Okay, so our noun, what are we talking about here? Well, v is velocity. So the velocity of the particle, okay, and our velocity the change in our velocity came out to be 6 meters per second. So our velocity increased, okay, by 6 meters per second. Okay, that's our units. And now we need the time. So on the time interval from 12 seconds to 17 seconds. So over that 5-second interval from 12 to 17 seconds, the velocity increased by 6 meters per second. Be sure you put a question mark by anything you were unsure about so that you can ask for clarification in class.